Hello, good morning. I'm Sudarshan Naik. Today I will teach about some doubt in the topic of Kepler's third law. During the proving the time period, a square of the time period is directly proportional to the cube of the perihelion distance or aphelion distance. You can say that the cube of the average distance between the revolving planet and the sun. So let's doubt clear about some student. Someone asked me about that the gravitational force is equal to the universal gravitational force. How it is equal to each other? Detail tell us. Okay. Then ask me, how can I prove gravitational force is equal to the universal gravitational force? Okay. Kepler's third law states that like this. This is Kepler's third law states that this is directly proportional to the R average. Can say average Q. During this proof, then we equalize force G, that is called force Fc. So Fc is equal to the force universal gravitational force. Let me clear and slip up speak. Universal gravitational force is equal to the centripetal force of the planet, which is revolving around the sun on elliptical orbit. So this is the centripetal force, and this is universal gravitational force. This centripetal force and universal gravitational force, how it is equal to each other, let it prove. Before going this, we recap about the Kepler's third law. Let it clear this one. Okay. Now we prove this one very fast. How it is state that the Kepler's third law state that the time period of the planet or time period of the any planet in our solar system, you can say Earth. Earth is also planet of our solar system. Earth is revolving around the sun one time period, complete one time period. You can say that you can say that one time period, and in the elliptical path, then it is a square of that time period is directly proportional to the average distance of cube of the average distance of the planet. That the distance it may be perihelion and aphelion. You can say the average aphelion and perihelion, that is here is. Okay, this is sun, this is S1, and this is S2. This is okay. This point is called perihelion. And its distance is 914.0043804. So you can say that just just write about like this. Okay, just write like 147.07 million kilometer, converted into kilometer, million kilometer, and it is kilometer, and then 147.07 into 10 to the power, this is million 10 to the power 6, and this is kilometer 10 to the power 3. Then 6 plus 3, that is called meter. This is the perihelion distance, and its perihelion distance and year of 2020, 4th January, the perihelion distance of Earth, this is called Earth, the perihelion distance like this, this is the distance, and this distance from Sun, this is called Sun. Okay, and this distance is called perihelion distance. 4th July, current year, this is the current year 2020, 4th January, past 4th January. So 4th January perihelion distance is, this is perihelion distance at the 4th January in the Indian Standard Time, that is 12:22 Indian Standard Time, 12:22 at the perihelion, and aphelion distance, that is called aphelion. So it is aphelion is distance how much? This is called aphelion distance. This is point P. This point is called, if suppose that Earth is here, 4th July coming next month, 4th July, year 2020, in the current year, the aphelion distance, this is called aphelion region at a point P2, and this is point P1. If the Earth at the year 2020, and it is 4th July, okay, 4th July, Indian Standard Time, that is 12.4, this one. Okay, in this Indian Standard Time, okay, in the Indian Standard Time, then its distance is how much? This is 152.1 million kilometer, and when you convert it into meter, then this is called million 10 to the power 6, and this is 10 to the power 3. When it is plus 6 and 9, this is called 9. This is called billion kilometer, 147.07 into 10 to the power 9 meter, and this is called billion. Billion is equal to 10 to the power 9. So here is billion, 152.1 into 10 to the power 6 plus 3 meter, and it is finally we can write here 10 to the power 9 meter, and this 9 meter is called 152.1 billion from the Sun. When the Sun is here S1, and it is the empty force. In this case, if the Sun is reached at 4 July, at that point, that will be the aphelion, and at the aphelion distance at 4th July, when Earth is reached at the 4th July at the point, and at this point is called the maximum distance from the Sun in the elliptical path. So here, when the Sun is moving here, this is sun is okay, let me read. Sun is moving very fast speed velocity, okay, and its speed is 30 kilometer per second, or 3 into 10 to the power 4 meter per second, okay. Its speed is mile per hour. Its speed is 6700 mile per hour. When it is converted 6700 into 1 mile converted into kilometer, that is 1.6009, that is called 1609 meter, that is called 1 mile, okay. This mile is put this here, that is this one, kilometer mile per hour. So here is 6099 meter. When it is converted meter, and this is second, that is 3, that is called miles. This is meter, this is miles, meter, and this is converted hour. Hour is 1 hour equal to 30 seconds. So you can write here 3600. When it is converted like this cancel, 670 into 1609 meter per second, and this is 36. When we multiply this one, for accuracy we help calculator. Where is my calculator? So here is my calculator. So this is calculator for accuracy, okay. So this is calculating this one, 670 into 106. Oh, sorry, this is wrong. This one is wrong. This one is wrong. 1.609, okay. Then we write here. So slip of write 10 is more written here. So let it forget it, let it correction. And after correction, this is 670 into 10 to the into 670 into 1609. It is converted into meter, okay. That is this one is 1079, sorry, 8 okay, 0 3 0 0.00, and this is 36. That is it. When it is converted 36, then how much it will be? 36. This is meter per second, and here we write the speed of the earth is here. Here is very important, because we know that when the earth is moving with the speed of very high on the orbit of elliptical path, in this case there will be the centripetal force. Whenever the centripetal force, then it will be the distance between each other. Whenever there will be distance in the space or in the universe, in there will be a universal gravitational force. Then we calculate each other and how it is equal to each other, centripetal force and gravitational force, universal gravitational force. So it is a process. So here is divided 36. Then it is come. Here we write, after here we write here, okay. Here we write, okay. Here we write like this. After calculating this one, and then it is 29.94 meter per second. So it is high speed you can say our escape velocity of Earth is 11.2 km per second, but here is huge difference, that is 30 km per second, approximate 30 km per second. So here is 30 km per second is moving on the speed. When the Earth is here, then its speed is 30 km per second, but here is centripetal force at here A, and here is centripetal force. This is the centripetal force, this is centripetal force Fc at B, just difference, because there the average perihelion something distance is quite difference. In this case, here the centripetal force, here is centripetal force is greater than this. In this case, the speed, there is the radius of, this is the radius of elliptical path in the region of perihelion region, okay, in the perihelion regions, and its distance is like just 147.07 into 10 to the power 9 meter. This is billion meter. So here is the centripetal force, here is also centripetal force, and this centripetal force Fc is B, here is B, is very greater than centripetal force and at A, the centripetal. In the same way, here the centripetal force, here the centripetal force is Fc, this is called C, A, B, C, okay, this is the centripetal force C, you can consider D, this is the D, centripetal force D at point here, and the centripetal force comparison. In this case, here centripetal force at point A, this is point A, at a point B, sorry, this is point B, this is point B, this is B, centripetal force B very greater than the centripetal force C at point D, this is called D, this is D. So when the Earth is moving like this direction, then the centripetal force is just decreasing, and here is centripetal force, when the centripetal, this is called decreasing, and here is the minimum, centripetal force, here the centripetal force is minimum, here is the maximum, 3.66 into 10 to the power 22 Newton here, and here is something difference, so here is maximum, here is lesser. So here now we calculate this one, how it is equal to each other, okay. So just clean this one. First we know here, while it is revolving around the sun, in this case one force is acting, centripetal force, and it is related to the orbital, force is inversely proportional to the orbit, radius of the orbit, or average distance of the elliptical orbit. Here is, suppose that the centripetal force C, that is called centripetal force, and this is mass velocity by r, and it is m into a acceleration, and here is a is the angular acceleration, it is angular acceleration, and v square by r. So here is, this is called force, F is equal to force, and this force is called centripetal force, circular, it is in a circular motion, this is the like a elliptical circle, elliptical orbit, then it is the complete, this is one complete cycle, and this is the sun, and this is the radius. We can say that this is the radius, and this radius is average. This is called perihelion. This is called perihelion. This is called perihelion plus, and this is aphelion distance. This is the aphelion distance, RFP. This is RFP, and divided by 2. This is called, when the distance is comes in, then after average this one, and comes in written as like this one. This is average, okay, or you can say that this one, okay, you can say like this, or you can say this like this. This is the average. This is the average distance. This is mass v square by average distance. This is equation 1. When Earth is moving in the elliptical path around the sun, and it's in the elliptical path like now. When the elliptical path here, and sun is here, and Earth is here, this is the distance is 147.07 into 10 to the power 9 meter. In this case, here is the galaxy. This is the our solar system, and after solar system there is the galaxy. This is called Milky Way. So it is all of this is the universe. So here is universe. Whenever the universe is present and two body is separated, heavier body attract a lighter body. That force is acting a line joining between them. This is the line joining between them. This is they call line joining between sun and earth. So this distance is called the line joining between them. In this case, earth and the sun present in the universe, then the universal gravitational force acting. So here is universal gravitational force Fg equal to G m1 m2 by r square. If there is the r perihelion, so you can say that this one is called m1. Mass of earth is considered m1, and mass of sun is considered m2. m2 is heavier. M2 is heavier. M2 mass of the sun, and it is 1.989 into 10 to the power 30 kg. And here mass of the earth is 5.97 into 10 to the power 24 kg. Now we look this one. It is huge distance. This is the huge difference. This is the heavier body, or you can say consider the mass of the sun. Total mass of the sun, or total mass of the our solar system, just equal mass of the sun here. So here is distance. This is the equation, and this equation we consider like this one. So here is I write freshly this one like this, okay. This one Fg, universal gravitational force, is like this, m1 m2 by average r square, and this is equation 2, and this is equation 1. This is m1 mass when the body is revolving in the elliptical path or circular orbit. In this case, the mass of which body is revolving in a constant speed on the orbit, then the mass will be here. and this is the centripetal force acting toward the center of the path orbiter. So here is the mass m1, mass of Earth, and this equation equal. This is the equal. So this is the equal. First we derive Kepler's third law, then prove why it is equal. How do we equal universal gravitational force is equal to the centripetal force? Okay, so let me prove Kepler's third law. Okay, so this one and this one equal centripetal force, universal gravitational. This is equal to each other. Okay, equal to each other. Whenever they equal to each other, let it prove. Later it would prove. First we derive this one, this and this. This is centripetal force m1 v square. This is the velocity of the Earth, very high speed, and this is average equal to g. This is called m1 and it is m2, and this is average s square. Here is m1, here is m1, so it is cancel. m1 and average n1 cancel from this equation, or cancel. So it is v square. Okay, v square. This is one, capital G. This is mass. This is called mass of the sun. Okay, this is average. This one, this equation come, and it is the time period. When it is related to the time period, then there will be the frequency. Whenever there will be the frequency, there will be the angular velocity, and the angular velocity is related to linear velocity, that is v equal to omega r. Okay, so we by this prove this one. When the revolving, that is velocity v meter per second, this is radius, this is the center, this is the body A, body mass of body m is revolving around the sun. In this case there will be the linear velocity, and when the periodic motion, this is the periodic motion, when you have the periodic motion, there will be the angular velocity, and angular velocity is related to the radiation r. This angular velocity, radius and velocity, linear velocity is related to v equal to omega r. So here is we put this one here, put this one. Okay, angular velocity, that is omega r average. This is called average velocity of Earth, is revolving in a all elliptical path or ellipse, on the path of ellipse around the sun. Then in this case there will be the average distance. So here we take the average distance like this, and this is the s square, this is the s square, and here is one, here the capital G, mass of sun, and there is average. But now we are here simplify this one. This is the average r, s square G, mass of 2. Okay, when simplify this one, here we simplify this one, we are going the detail, we everything consider, everything understanding what is the reason behind it. When it is proved time period of Earth, time period of any planet of a solar system, even Mars, Jupiter, Venus, Uranus, Neptune, except Pluto. So here is prove this one, that is omega square, and this is omega square is this one, omega square is this, like G mass of sun, and that is Q. Here is R S square into R, so 1, so it is S square. Okay, now this is the angular velocity. There will be a frequency, 1 rotation, 2 rotation, 3 rotation, 4 rotation, every 4 year our leap year. So every 4 rotation there will the frequency. The angular velocity is related to the time period. One time period, like our time period is 3.14 into 10 to the power plus 7 second. This is called 1 year. In 1 year, 365 day at the rate of Earth, which revolve east to west. Very high speed, approximate equal to 700 kilometer per hour on axis. Okay, so here is approximate equal to 700 kilometer per. So here is according to Earth day. There is a time period is how much? T is equal to 3.14 or approximate 3.15. You can consider this one. Something is here. This is plus 7 seconds. This is the time period of the Earth while it is revolving on the elliptical orbit. After 1 year, the total second is this 3.14 into 10 to the power 7 second. You can say that 3.1 like this, 3.4 into 10 to the power 6 second, or you can say that 31.4 million second. This is the second for 1 year. So here is angular velocity. Here angular velocity is related 2 pi by t. This is S square. Here is 2 pi by t. We know that that is G mass of S square, and this is R Q. Here angular velocity is related to the theta by t, and when theta is complete one rotation, complete one cycle, this is called 0, and this is t by 4, and this is t by 2, and this is 3t by 4, and this is called t. This is called 1 year, and 1 year 365 days. This is 5 days. The time period is here. Total completed 360. That is called pi radian, 2 pi. Here is 2 pi, and this is called 2 pi by t. When it is proved like this, and here is put here, then 4 pi r square. Sometime written s square. Slip of right last class. You just read correct. Okay. When I write flawless, very fast, then a slip of writing. So here is slip of not. This is not s square. This is called s square. This is s square. Okay. You can say right here. This one is s square, total s square. 2 pi is a whole square. Then it is simplify this one. Then it is. So this is s square, and this is q. Q. Here the time period. We have to find out the time period. Okay, time period kept left hand. Just cross my multiplication. Okay, after cross by multiplication, it is comes, that is 4 pi s square q, and this is g mass of r. This is called time period. It is left, kept left. Time period, this is called time period of the earth, that is 4 pi s square universal gravitational constant, and this is m2. This is all are the constant. This is called constant, and this is average distance. Okay, this is 3, and this is the constant. Whenever it is constant, then it is we write here s square of the time period. This is the s square of the time period of any planet which is in our solar system and revolving in a fixed orbit except Pluto, directly proportional to the average. That is the average. Here is average, this is the average. This is average distance, average radius of the elliptical path, average distance from the revolving on a orbit to the center, distance between the revolving of the revolving planet on the orbit, fixed orbit, to the center, distance between them, and then it is line joining between them. Here is line joining between them. Here is sun, and any planet is moving here, planet. Here is distance. Here is distance. Here is planet. After this second, after here, after that, this, that, and there is the distance. This, when you average distance, it is average perihelion. This is the perihelion, and this is the aphelion. When it is peri, and this is aph by 2, this is called r, average. So here is r. This is, and this is constant. Here is constant. Here is constant, this one. Mass. Here is constant. 4 pi, constant. R, a pi, this is called constant. Pi, this is called constant. 3.14. G is constant, 6.67 into 10 to the power 11 Newton meter square per kg square. Mass of sun, 1.99 10 to the power 30 kg. All are the constant. Here is constant. So here is constant. That's why time period of the any planet, s square of the time period of any planet is directly proportional to the average distance of the elliptical path. Any planet which is revolved in a fixed orbit around the sun, provided that there will be a fixed elliptical orbit. Our 8th planet has a fixed elliptical orbit except Pluto. So this rule is implemented 8th planet. Which type of 8th planet will be? Here is 8th planet. Sun, okay, this is the sun, this is Mercury, this is Venus, this is Earth, this is Mars, this is Jupiter, this is Saturn, this is Uranus, and this is Neptune. 1, 2, 3, 4, 5, 6, 7, 8. This all planet. The time period of the planet, all this 8 planet S square of the time period of any planet of this one which is in our solar system. Solar system is directly proportional to the average distance. Here is the average distance q. This is the proof of. While it is proved, now we prove centripetal force is equal to the universal gravitational force. Let this prove. Okay, comes with me and understand carefully. So clear this one. So let this one. Something not rubbing this one and clean. So enough clean here. We can write here like this. We can write here centripetal force. First we calculate the value of centripetal force, numerical value of centripetal force. While it is centripetal force of any planet, we consider Earth. We are the human being of the Earth or alien of the Earth. So we taking Earth. Okay, mass of Earth we know, velocity of Earth we know, and the perihelion distance and aphelion distance also we know. Okay, so we calculator, we use the calculator. So we use the calculator. Okay, so dear student, understand slowly but perfectly. Here centripetal force, see, that is called centripetal force. Okay, we know the centripetal force, that is mass of R. This is called mass of the body which revolves in an orbit of a fixed radius with constant speed or velocity. Okay, suppose that this is the fixed orbit and this is revolving in a constant. This is constant. Okay, constant speed in the circular motion. In this case, this and this is the mass and this is the fixed orbit and the velocity, and in this case there is the centripetal force acting, because acceleration is v by r square. Here is something difference, be very fast. This one is theta and this is the relation. This is the relation delta L. Theta, arc and radius. It is related to this is theta is related to arc by radius. Arc by radius. Equation 1. When the velocity is here v1 and v2, they are the constant speed. v1 equal to v2 equal to constant, and it is consider v. In this case, there will be the distance is equal v1 and v2, and v1 minus v2 minus v1, that is called delta v. When the delta v is here, this is dash delta v is related to the arc delta L. So here the theta, that is same angle. This is the same angle, and the distance ratio of the changing of velocity, and then the fixed velocity, constant velocity v, and is combine this one, then it will become delta v upon v equal to delta L upon R. Okay, this is this one, and here is delta V equal to delta L upon R into V. This is constant, this is also constant, this is constant, and velocity is also constant. So here is delta V equal to V by R and delta L. But we have to find out acceleration. What is the acceleration? Suppose I'm asking you a question, what is the acceleration? You can say acceleration is nothing but it is the rate of change of velocity. So here is rate of change of velocity. Here is rate of change of velocity 1 by delta t. Here delta t, and this is called V R, and this is called L by delta t. This is the instantaneous velocity. Now it is average. What is average? That is, later we write here, proving this one. This is a proving. In the elliptical path or orbit, any orbit, when it is r, when it is mv square by r, then it will be the elliptical r. This is the radius. Radius is just changing. Here is radius is fixed, but it is like a circle, like moving in angular velocity. There will be a time period. Here is also time period. So there will be a time period. There will be in a fixed orbit. When the moving in a fixed orbit, there will be a time period. Whenever there will be the time period, here is the angular velocity. There will be the velocity, angular velocity. So we find out the angular acceleration. There will be angular acceleration. Here is angular acceleration AC equal to V square by R. Here is proving this one. We write here. Here we write. Okay. Here is something place we have to prove. Okay. I am answering a student which is asking, how, sir, how do we equal each other? Centripetal force and universal gravitational force. Proving centripetal force is equal to or approximate equal to universal gravitational force. This is proving. Here there is taking limit both sides. This is equation 1, equation 2, then this is equation 3. In the equation 3 we taking the limit, taking limit in equation 3, delta tends to 0. So here limit delta tends to 0, that is delta V by delta t, and this is limit delta tends to 0. Here is something cut here, so we write here very a small write, limit delta tends to 0, that is V by R and delta L by delta t. This is the constant. V by R is constant, so brought a common limit, brought a common, and this is delta tends to 0, and this is delta L by delta t. Okay, here is called dv by dt, and here is dr by here by dt, here by dr by dt. This is called angular acceleration. This is v, and this is r. Here is delta L by delta t, or you can say the s by t. S by t is called velocity. So this is the instantaneous velocity, this is the instantaneous velocity, and this is velocity, instantaneous velocity, instantaneous velocity. While it is body, when the body is moving in a fixed orbit. So here is, this is V square by R. This is here. This is the fixed orbit, this is the fixed orbit, and this is the average orbit. in the elliptical. Now we prove this one. So here is calculator and proving this one. Okay, let me prove this one. So here mass of planet, that is earth m1. Okay, this is called m1, this is called m1 and this is called m1, that is 5.97 into 10 to the power 24 kg. Here velocity is how much? That is, velocity is very high speed, 30 kilometer, approximate 30. So exact value we are taking here 29.94 kilometer per second. Here we are taking this one, and then it is the average distance we are taking. Okay, the average distance is like taking this one. Average distance is how much? Delta r, average distance, perihelion and aphelion distance, aphelion distance. So we consider at the region of any regions, not we consider at the f fixed orbit, like this one, This is sun, this is the earth, this is the distance 14.07 into 10 to the power 6 kilometer, or 147.07 into 10 to the power 9 meter. Okay, we prove this one. Here the perihelion distance. So suppose that it is the perihelion distance. Okay, this is called perihelion distance. So mass of the earth 5.97, 10 to the power 24. Velocity of the earth, this is kilometer, that is 29.94 into 10 to the power kilometer, that is called 3 meter per second. This is called 3 meter per second. Okay, so here we consider this one 2.994 into 10 to the power 30. This is called 4. Okay, 4. When the point is shifted left side, 10 to the power plus 1 after one digit, so we add this one. So here is 10 to the power plus 1, and here is also 10 to the power 3 meter per second. That's it, 2.994 into 10 to the power 4 meter per second. This is the value. Here we write 2.994 into 10 to the power 4. Here we just rub this one, and this is the s square, and this is the perihelion distance is how much? This one is 147.07. This is only billion kilometer, 10 to the power 9. Okay, so here is just perihelion distance. This and this multiply, 2 times multiply here, 5.97 into 2.994 square. This is 24, 10 to the power 24. Here is 4 plus 4, 8. That is called s square of the, due to s square, 10 to the power 8. And here is 147.07. It is 10 to the power 9. Calculating this one. Okay, s square of the 2.994 into 2.994, that is called 5.97 into 8.96404. Okay, and this is 32, 10 to the power 32, and this one is brought numerator part, then it will be changed their sign, and it is 47.07. Now it is calculate this one. Okay, calculating this one. So first we calculate this and this, that is multiply with this one, 5.97, and it will be 53.51, and it is 147.07 7 into 10 to the power how much? That is 23. Okay, it will be 23. This one is simplify like this. It is divided by 147.07. okay, then it will be 36. okay, there will be a 36. There will be a 0.36 0.363 and 0.36388. okay, this is okay. Now 10 to the power how much? This is 23. 10 to the power 23. When point shifted like this one, then it will be 3.64. you can say that this is 3.6388 into 10 to the power minus 1 and 10 to the power 23. Then it is simplify this one 3.6388 into 10 to the power 22 Newton. This Newton force, huge Newton force acting at the perihelion distance when the earth is 4th January, and in this case 147.07 million distance. Indian standard time is 12.22. okay, when the earth is at the 4th July, then the centripetal force is like this. And in the same way, how much value of universal gravitational force at the 4 January at this perihelion distance. Now we prove. But consider this one, we write at top of the whiteboard. This is, we have to find out. This is 3.6388 into 10 to the power 22 Newton. This is at the perihelion. This is the centripetal force. Okay, this is the centripetal force at the perihelion. Now we find out the universal gravitational force. I clean this one. Okay, so proving this one, always we know that whenever the universal gravitational force acting, there will be the two mass will be present, and the distance between them, the line joining between them, something difference. So we prove this one. Okay, like this one. Here is 4th January. Here current Indian Standard Time 2, and its distance, perihelion distance, that is called 914 mile per second. When we calculate this one, this is 914.26384 into 1 mile. Here 1 mile equal to 1609 meter or 1.609 kilometer. So here is 914.26384 4 into 1609 meter. So it is, calculate this one. Okay, this is the calculating this one. 9142638 into 1609, that is called how much is distance, like this one. This is how much distance like this one. So it is approximate equal to, this is 1471050. Okay, this is a point, this is point, and it is 10 to the power 11. So it is called 10 to the power 11 meter. That is called, it is meter. Meter converted, this is called meter. So here 4 point, that is how much distance is here, 10 to the power. Suppose that this one is the 1 2 3 4 5 6 7 8, that is this is point, this one. Okay, this is the point, that is the kilometer. Okay, so here we write here 994, same thing, so same will be same thing, but we converted this one. So here 9426. For accuracy we use the calculator, not mind. So here 36384, 91426,384 into 1.609, that is how much, that is 1471050,519. Point, this was 9. So here is point, this is called kilometer, and that is kilometer when the point is shifted like this one, that is called 1, like this one. Here is shifted this one. Suppose that this one is shifted here. Suppose here we considered here billion kilometer, 1 2 3 4 5 6, this is called 10 to the power 6 billion kilometer. 147.1 into 10 to the power 6 kilometer, and it is 147.1 into 10 to the power 6 into 10 to the power 3 meter. So it is the billion kilometer, 147.1 billion kilometer, 10 to the power 9 meter. This is called billion kilometer, 147.1 billion meter, billion meter at the perihelion distance when the earth is reached at 4 January Indian Standard Time 12.22. In this case, here is the perihelion distance, there is the perihelion distance. Perihelion distance is here. We write just approximate equal to, this is the fixed value 7.007. It is the, like we consider this at 1. So here is the billion kilometer. Now we prove this one. Okay, now we clean this one. First we clean this one. This is the distance. Okay, something not cleaning properly, very hard effort. Okay, not cleaning properly, but this is 147.1 billion meter. Okay, that is enough. Okay, now we write here, this is when the, here is sun, this is mass of sun, that is m to 1.99 10 to the power 30 kg. Here is earth, mass m1 97 10 to the power 24 kg. distance, it is the perihelion distance. This is line joining between them. This is line joining between them, and this is line joining between them. This is the centripetal force is here. So there will be the universal force, attraction, universal force, that is Fg, and the distance is peri, that is 147.1 into 10 to the power 9 meter. Here is the distance, mass is here, and universal gravitational constant is here. Universal gravitational constant. First, you know that when the two bodies present in the universe, here is solar system, here is solar system, and here is the universe, here our galaxy. This is the Milky Way. Here is universe. Universe. When the two body present in the universe at a particular distance, there will be the universal gravitational force acting each other. Heavier body attract to the lighter body toward the center. So here is heavier body is how much? This is the heavier body, mass sun, heavier body is mass, huge mass. This is the huge mass. Huge mass of sun. This is the lesser mass of than sun. Mass of sun is very greater than mass of earth. So here is heavier body. This is called heavier body, and this is called lighter body. Lighter body. So universal gravitational force is here. Universal gravitational force is directly proportional to m1, m2, and universal gravitational r square. This is the perihelion. This is the distance is perihelion. This is perihelion. So when we combine this one, equation 1, equation 2, combine this one, Fg m1 m2 by r perihelion square. Then it is remove, that is universal gravitational constant. Let me prove how it is come. Universal gravitational constant. Why it is called universal gravitational constant? It is so this one is because everywhere is constant, so it is called universal gravitational constant, and it is the fixed value for any planet of the universe, provided that there will be a heavier body, there will be a physical world or universe. The universe value m1 m2 by perihelion distance. Okay, now put the value of here. After putting the value, calculating, and then simplified this one, and after simplification if we find this one, then that will be the equal to like approximately equal to like this force. Then we consider it is equal to each other, centripetal force and universal gravitational force. So let it put the value. This is the value. Okay, we all know about the universal gravitational constant value 6.67 into 10 to the power minus 11 Newton meter square per kg square. Mass of earth, that is 5.97 into 10 to the power 24 kg. Mass of sun 1.99 into 10 to the power 30 kg. Perihelion distance r perihelion 147.07 approximately equal to 147.1 10 to the power 9 meter. So we put this word 6.67, okay, 10 to the power 11 5.97, also 10 to the power 24, mass 1.99 into 10 to the power 30 kg. This is upper side. Now it is 147.1 into 10 to the power 9, this is a square. Calculating the first, we calculate this and this and this, that is called 6.67 into 5.97 into 1.99. okay, then the exponential is here 10 to the power minus 11 plus 24 plus 30. okay, and this is calculating this one 2 times a square of the, this is 147.1 into 147.1, that is 21638.4100 into 10 to the power 9 plus 9, 10 to the power 9 plus 9, 18. okay, now we calculate this one, this 6.67 into 5.97 into 1.99, how much? That is 79.2416. okay, and this is 21638.4041. This is the calculating this one after calculating 10 to the power minus 11, and this is called 54. This is called plus 54. okay, plus 54, and it is brought upward direction, then it is 10 to the power minus 18. So here is calculating this one. We calculate this one. This point is like this point, like this one 79. Here we write here. This is the universal. Here we write. okay, here we write, this is the universal gravitational force. Universal gravitational force, that is how much? 79.2416 upon this one. This shifted it like this 21,638.4. the point is shifted like this, 2 digit after 2 digit, then it is 10 to the power 1 2 3 plus 3. So here plus 3 to 1.6384 into 10 to the power minus 3. Here 10 to the power minus 11, and this is called 10 to the power 43. This is called 43. okay, 43, and 10 to the power minus 18. This is minus 18, and this is goes upward direction, that is plus 3. So it is 79.2416 and 2.1638. okay, 10 to the power 43 and minus 46. okay, 46 minus 18. So calculate this one. We use this one. This one is divided by 21.638, 36.6 something, 36.6, 3.662 into 10 to the power, that is called 18. That is called how much? that is called that is 16.8. okay, and this is 3.2. here is something difference value, so we check this one. First we check, okay, this one and this one 54 and 11, this one and this one, this is 18 minus 18, minus 18 is noting this one, this is 46 minus 18, plus this is called plus, okay, this is minus, this will be minus, okay. Here is when this is plus, when is it plus, this is 10 to the power plus 3, when it is moved like this direction minus, this will be minus, so upward direction. Here is 10 to the power 43 minus 18 minus 3, so here is 43 minus 21, okay, so 3.66 into 10 to the power 22 Newton. But here is something difference, here is something slight distance where we recheck universal gravitational. Universal gravitation is like here, this is called universal gravitational, like this Newton force, this is okay, but recheck this one. Let me recheck this one. Firstly recheck this one, something wrong or recheck. Centripetal force, that is centripetal force, like this centripetal force. Centripetal force, mass of m1 v square by, like this, centripetal force like this, okay. Centripetal force is like this r, so 29.94, approximate value is 30, then how it will come, this one, okay. 5.97, okay, this one, and 10 to the power 24, velocity is how much, 29, 30 into 10 to the power 3, okay, 2, and this is apparent distance 147.1 distance into 10 to the power 9 meter, so 5.97334, you can say this is the 4, 3 into 10 to the power 4, okay, 339, this is called 9, okay, that will be a 9, s square of the 3, 9, okay, 339, and this is 10 to the power, this is also 24, and this is 88 plus 8, and this is 147.1, and 10 to the power 9, it is 10 to the power 9, so we calculate this one, 5.97 into 9, how much, 53.73, okay, and this one 147.1, 10 to the power 32 minus, this is minus, this goes upward direction, then it will be change their sign, 9, okay. We prove this one, divided 147.1, that is 1.74, like this, 0.36526 to 10 to the power 22 Newton. Here is like this and here is like this, so when shifted 33, when shifted this one, 3.6526 into 10 to the power minus 1, 10 to the power 23, that is called 3.653 into 10 to the power 22 Newton. This is, and this is just equal. Now exact value how can we come? So here we exact value, we are taking the exact value, not 30 kilometer per second. We taking the exact value, that is 29.94. okay, here is 29.94. we taking here like this one. Here we taking, suppose here we taking another we taking, that is 5.97 into 10 to the power 24. Here we 29.94 into 10 to the power, that is 3, okay, and a square, and this is called 147.1 into 10 to the power 9. okay, so this and this 59.7 into 29. okay, now we calculate very fast. 29.94 into 29.94, that is 896.40 36 into 10 to the power 6, 10 to the power 6 plus 24 plus 24. okay, and this is 147.1 into 10 to the power 9. So here we write this and this, multiply this one. This one is multiply with 5.97, that is 53 51.529, okay, 49. So we add this one, 30, 24 and 6, 26, 30, and here is upward direction, that is called -9. So here is 147.1. so here is divided by, then how it's divided, it is divided by 147.1, 36 point something, there is something difference. okay, this is the approximate one, nearby the, this is the just equal to each other. You can say that it is something less value representing in the same, this is the representing value of this one. But here is, if we taking the 30 kilometer per second in this case, 30 kilometer per second in this case, if we taking the average value, oh sorry, this is the average distance. So average distance, how much is it? This is the average distance we are taking, have the average distance like this, 5.97 into 30 kilometer per second, 30 into 10 to the power 4, this is 10 to the power 24, and this is the square, and average distance, what is average distance? 147.1 plus 152.1 divided by 2, that is called how much? 147.1 plus 152.1 equal to 299.202 divided by 2, that is called 149.600. This is the average distance, or you can say the average distance just approximate equal to 150 million kilometer, 10 to the power 9 meter, or billion kilometer. This is 150 million kilometer from sun and earth. So million kilometer, and this is meter. So approximate is equal to this one. So we put the value of this one, 150 into 10 to the power 9. Then it is how much it is, and it will be how much? 5.97 into 9 divided 149.6, that is 5.6. So just approximate equal to, like this one is, so you can say that like 2 digit, just 2 digit centripetal force, this is centripetal force, just equal to this one. So it is just approximate equal to this one. It is centripetal force is how much? 3.65 into 10 to the power 22 Newton, just approximate equal to 3.66 into 10 to the power 22 Newton. So here we consider this one, the centripetal force is equal to the universal gravitational force. When we approximate equal to this is the fractional, this is something fractional, this is something fractional part, this is approximate, the approximate is this one. So it is considered this one 3.7 into 10 to the power 22 Newton. Here we approximate 3.7 into 10 to the power 22. So here is equal to each other. Here we equal, approximate equal to 3.7 into 10 to the power 22 Newton equal to 3. This equals 7, 22. So here is equal. So how can you consider? Same we consider centripetal force is equal to the universal gravitational force, equal each other. So here is proof. Dear student, look there, this and this will be equal. After equaling this one, then we find the time period of the directly proportional to average, that is called average Q. This is called Kepler's third law. Okay, thank you for watching this video. Thank you so much. Keep watching.